Welcome to H.W. deVries Green Building video. The following is intended to explain the design goals, construction methods and specifications we use to build a healthy green home. The design goals for the home are long-lasting quality construction, superior air quality for the health and comfort of your family, energy conservation for reduced operating costs, and sustainability for the conservation of materials. We have placed indoor air quality at the top of our design goals as it can have a direct impact on health, some individuals more than others. Indoor air can be much more contaminated than outdoor air. Indoor air can become contaminated in a variety of ways. Radon vapor is a cancer-causing radioactive gas. It is the second leading cause of lung cancer. Mold is directly related to moisture. Moisture can come from many sources in the home: stormwater, groundwater, and water vapor in the home. Volatile organic compounds can have a large impact on the indoor air quality. VOCs can come from common construction materials such as paints, adhesives, sealant, carpets, and some manufactured wood products. Many VOCs are known to cause cancer. Mold is the result of a moist environment. Mold is not the only negative result of excessive indoor moisture. It is the first indicator we see and has become the alarm call for corrective action. Researchers know that many people that are sick in a moldy environment are not always allergic to the mold. The first elements of the home are associated with the site work and foundation. To achieve the goal of superior construction quality and air quality, we need to construct the home with a dry basement and a site that controls the groundwater. The following video shows the steps we take to keep the home dry and reduce the likelihood of radon gas in the home. There is reinforcing steel in the footings and foundation walls. This makes the walls stronger and less likely to develop cracks that can lead to water and vapor entry. We have placed crushed stone under the foundation and basement floor. This will help us control groundwater and let us ventilate any radon gas that might be under the floor. There is water stop material between the foundation footing and wall to prevent any groundwater infiltration in this area. The water stop material has clay in it, and when water comes in contact with it, it expands, filling any voids and stopping any water infiltration. We also use reinforcing steel to connect the wall to the footing. This combination of water stop and steel make the foundation very strong and dry. The foundation is waterproofed, not just damp-proofed. Waterproofing can span small cracks that might happen, stopping water or vapor from penetrating the wall. There is a 5-year warranty on the waterproofing. We have installed footing drains around the perimeter of the foundation to drain off any groundwater. In preparation for the basement slab, we've placed water stop at the inside perimeter of the basement around all the columns and around the radon vent pipes. This will prevent any groundwater from getting in and helping us reduce radon gas from penetrating the home. There is a vapor barrier under the slab to prevent any radon gas or water from coming up through the floor. The vapor barrier is specifically designed to keep water and radon gas out. As you can see, to get the home to this stage, we've done many things that are not part of your average production home. It is the attention to the design and execution of the site work, foundation, and basement floor that will add value, livability, and help prevent moisture and radon problems that can result in indoor air quality and health problems in the future. The next phase of the construction is the framing of the home. This is where careful planning, material selection, and execution are critical to meet our design goals. We use engineered wood products when possible. The use of engineered wood products is more sustainable than solid wood. The floor joists are engineered and result in a superior floor system. You get a flatter, more stable floor with much less likelihood of squeaks or crowns in the floor. We try to get our lumber from sustainable forests. We use solvent-free adhesive to glue all the floor sheathing. It is at the conclusion of the framing that we start the process of sealing the home. It is important for energy efficiency and indoor air quality. We install a continuous Tyvek type air barrier product to the exterior of the home and tape all seams. This reduces air infiltration into the walls of the home. It improves energy efficiency and reduces the possibility of moisture in the walls. When the windows and doors are installed, Sealant is applied to all mating surfaces. The windows are further sealed with peel and stick air and vapor barrier that is applied to the exterior flanges. This is done to keep moisture out and prevent air exchanges in the wall. The siding is an often overlooked element of the home. It is commonly installed incorrectly and penetrations not properly flashed. The windows we have selected have an integral flange made to accept the siding, improving weather resistance. All the vents in the home have a siding flange. All other penetrations in the home are properly flashed. This helps keep out moisture and reduce the possibility of the resulting mold. The final steps in the construction of the exterior envelope of the home are the air sealing and insulation. The air sealing consists of applying sealant to all the intersections of the framing inside the home. This keeps outside air out and conditioned air inside the home. The insulation we've selected is dense, packed cellulose. It has much greater performance than fiberglass insulation. The first advantage is the installation method. It is blown in and packed in the wall cavity, filling around wires and pipes completely. Fiberglass does not fill these voids and allows air to circulate in the wall cavity. It is much more likely to create an environment in the wall that mold can grow. The basement walls are insulated with 2-inch foam board insulation and covered with mold and moisture-resistant sheetrock. There are many advantages to insulating the basement this way. This keeps the furnace and ductwork inside the insulated envelope of the home. This is more energy efficient. Another reason was to eliminate the commonly used exposed fiberglass insulation in the ceiling of the basement. We've tried to reduce the use of fiberglass insulation in the home whenever possible. We believe exposed fiberglass insulation can and does end up in the home. It is at least an irritant. We also do not use fiberglass ductboard. It is commonly used and has the air in your home going through exposed fiberglass ducts, then into your home. We locate ductwork in interior walls and condition space whenever possible. It is common practice to locate ductwork in the exterior walls. There are several problems with putting ductwork in the outside walls of a home. You are taking heated or cooled air and passing it through a duct that has very little insulation between it and the outdoors, then bringing it back into the conditioned space. You also have a reduced insulation value where the duct is in the wall. Finally, if you have any duct leakage, that conditioned air goes outside the building envelope and you lose that energy. Now it is time to install the sheetrock. In any area there could be a moisture problem, we use mold and moisture resistant sheetrock, not just moisture resistant. At the conclusion of the sheetrock, we do the first major cleaning of the home. This is where a lot of times several pounds of dust is left in the home and over the years works its way into the living space. We wipe down the walls and vacuum all the electrical boxes, the floors, and around all the doors and windows. We will do another vacuuming just before the flooring is installed. The paint we've selected is Benjamin Moore EcoSpec paint, specifically designed to be used in healthcare facilities and where indoor air quality is important. It is low VOC and low odor. We are using a VOC-free sealant for all of our sealing. The HVAC system has a high-capacity, high-efficiency filter. There is a central vacuum system installed that is exhausted outside the living space. This is a much more efficient method of cleaning. We have a garden hose hookup in the garage that has hot and cold water piped to it. This can be used to hose out the garage any time of year and reduce tracking dirt into the home. Now that we've taken all these steps to build a very tight, energy-efficient home, we need to manage the indoor air. The trend toward building tight, energy-efficient homes has in some instances created unhealthy indoor air. As I outlined in the beginning of the video, our primary design goal is the health of the family. We've installed many exhaust fans in the home. We think the best way to manage moisture is at the source. So we have motion-controlled silent exhaust fans in all bathrooms and in the garage. There is a kitchen exhaust hood over the stove. All fans are ducted to the outdoors. We decided to join the Energy Star program for the third-party verification of the performance of our homes. According to Horizon Residential Energy Services, who reviewed our plans for the Energy Star program, our first home surpassed the requirements by 21%. In the end, we have an energy-efficient, healthy home. Thank you for taking the time to watch this.